Now another example of relative velocity method is discussed now. Here the OA is 100 millimeter and QC is 100 millimeter, and AB and QB is 300 millimeter and CD 250 millimeter, and the rotation of OA is 150 rpm in clockwise direction. Now determine the velocity of the slider D and the angular velocity of the link QB and AB, and the rubbing velocity of the point B is 40 millimeter in diameter. So in the question, OA QC is given, AB QB is given, and CD is given. Now omega is 150 rpm, that is given. Omega is the angular velocity of the crank. Now we have to find the velocity of the slider. D. So if omega is given of crank AB OA, and that is in clockwise direction, so the velocity of A with respect to O, velocity at the point A is omega into distance OA omega means 2 pi n by 60. N means 150 rpm is given, and the OA distance is 100 millimeter into 10 to the minus 3, so that is millimeter. So the velocity of A point with respect to O is 1.57 meter per second. Omega 2 pi n equal to 150. Now draw the configuration diagram at a scale, at a particular scale. Here the diagram is given, so we draw the configuration diagram at a particular scale. So I consider 300 millimeter equal to 3 centimeter scale. In scale 3 centimeter equal to 300 millimeter. Then OA or QC, that is 1 centimeter scale, 100 millimeter, so 1 centimeter scale. 300 means 3 centimeter, so 100 means 1 centimeter scale. Now AB and QB equal to 3 centimeter scale. And CD equal to 2.5 centimeter scale, 250 millimeter, so 2.5 centimeter scale. Now The angle is 35 degree. $35. The crank distance is given 1 centimeter scale. From this angle, crank is rotated with respect to this point, that is 1 centimeter scale. One centimeter, and the angle is 35 degree. Here developed pair is present. Now AB distance 300 millimeter, so in scale 3 centimeter, and this distance QB is 300 millimeter, in scale 3 centimeter. Here the distance is given 280 from point O to point Q. 280. Okay, from point A centimeter arc is draw, and the distance is 230, so 2.3 millimeter centimeter scale. Vertical, (230 centimeter vertically), so 2.3 centimeter in scale. (2.3 centimeter). And horizontal distance is 280 millimeter horizontal distance, so 2.8 centimeter scale. from point O to Q. Horizontal distance 2.8 centimeter scale. That is the point Q. From point Q, 300 millimeter which is intersect B. So 3 centimeter scale, draw a arc from the point Q. Three centimeter scale. This point, the intersect point is B. The length is QB. Now the QC is 100 millimeter. That means one centimeter scale QC. This side is 50 millimeter from horizontal line Q. $50 millimeter. Draw a line. So length is 250. From point C, the length is 250. So 2.5 centimeter in scale. And the intersect point is the point D, that is slider. Slider. Draw the slider here at the point D. Here this line, that is AB. So the configuration diagram is complete. There is point O, A, point B, C, O, Q, and point D, that is G. Here Q and G and O are fixed point. Now draw the velocity diagram. After finish configuration diagram, draw the velocity diagram. O, G and Q fixed point. Now the velocity of point A with respect to O is known, and that is velocity of A with respect to O (1.57 meter per second). So I consider that is equal to 3 centimeter scale. So OA is 3 centimeter. The velocity of A is 3 centimeter in scale, and which is perpendicular to OA. The direction is perpendicular to OA, and which is passing through O, point O, because velocity of A with respect to O. So the velocity direction, and if that is clockwise, so the velocity direction along this, and now the parallel line from the point O. Draw the parallel line from the point O, Q or G. So support another point, another here. This is the parallel line. Parallel line. And that is equal to 3 centimeter in scale. Centimeters. Now the velocity at the point B, which is passing through C and A, and where intersect, that is the point B velocity. So velocity point B with respect to C, which is passing through C, velocity that is perpendicular distance, perpendicular direction along QB, and velocity of B with respect to A, which is passing through A. These two lines intersect where, that is the point B. velocity in velocity diagram. So that is point A. Now in AB, the perpendicular line which is passing through A in velocity diagram. So the parallel line from point A should be drawn in velocity diagram. Support another side and the scale slide. Draw the line. So this is the parallel line of the velocity direction. Now with respect to C, velocity of B with respect to C, the perpendicular on QC which is passing to C, QB, velocity of QB, not QC, B, not CB, QB. C is the intermediate point on the link QB. So velocity of B with respect to Q which is passing through Q, and that is perpendicular. So draw the perpendicular line from Q fixed point. The Q fixed point this line, parallel line from Q in velocity diagram. So this point is B. Now point C on the link QB. And that is velocity of B with respect to Q divided by velocity of C with respect to Q equal to QB by QC, and from this relation we get velocity of C with respect to Q that is 300 by 100. The ratio is 300 by 103. So V of BQ and V of CQ, the ratio is 3. That means V of B with respect to Q is 3 into V of C with respect to Q, 3 times. So here the total length is known, and then the 1/3 of the length (3.6), then 1.2. So C distance is 1.2. C. Now velocity at the point D. Here velocity of D with respect to C and velocity of D is sliding horizontally. So velocity of D with respect to C perpendicular and which is passing through C, perpendicular line which is passing through C, and draw this perpendicular line in velocity diagram from point C. Now the velocity of D with respect to G, the fixed point G, which is sliding along Q dq. So the parallel line and these two lines where intersect, that is the point D slider. So now this distance q d is the velocity of slider D. Velocity of D with respect to Q or G. So in scale the distance is (1.1). So 3 centimeter means 1.57 meter per second. Then 1.1 centimeter means 1.57 divided by 3 into 1.1. So that is 0.57 meter per second. Now the velocity of A with respect velocity of B with respect to A if we measure this distance, we can determine the velocity, and also we can determine the velocity of B with respect to O, fixed point O. By measurement. Now the omega, the angular velocity of the the angular velocity of the link B with respect to Q. BQ is 3.6. So velocity of B with respect to Q divided by the length BQ or QB, and also we can determine the angular velocity of link AB. The angular velocity of B link AB, velocity of B with respect to A divided by the length AB. Length AB is 300 millimeter. Now rubbing velocity at the point B. At point B, QB and AB intersect point B. So the rubbing velocity at the point B formula is omega AB minus omega BQ, omega BA minus omega BQ into RB, the radius is given. So that is the rubbing velocity at the point B.